Hello and welcome to this Mastering the Machine webinar for the 14th of January 2022. Our topic today was industrial automation training in all its different forms, and we had a really good time, and thanks for checking it out. Good morning and welcome to this Mastering the Machine webinar for the 14th of January 2022. And today's topic is industrial education. And I'm going to be talking about a lot of different types of education today, everything from college to online training to in-person classes, a lot of the things that I'm involved in. Before we do that, I'm going to go ahead and get some of these basic things out of the way that I always do at the beginning of the webinars. Again, what is Mastering the Machine? It's named after a document that I put out in 2013 called Mastering the Machine, and it was about procurement of machinery, quoting, and pricing of machines, things like that. And I actually use it as a lead magnet to get people's email addresses to spam them, right? Actually, I'm not much of a spammer, but I do send newsletters and things like that out that pertain to the efforts that I'm working on. And one of those efforts is the Automation Academy, which is the host of this webinar that I do every 2 weeks. So it's turned into a bi-weekly webinar and a website. And you can find the website right here at automationllc.com, join or academy/academy. What is the Automation Academy? We have training videos for Allen Bradley, Siemens, and Omron PLCs. It kind of started as a PLC training site, but has migrated into becoming more of a systems integration site, which is a lot of what I do. I do programming and systems integration for various companies, and I put a lot of my documents and videos and things like that here. On the Automation Academy, there is a library of documents. There are a lot of videos. There is a community where we have some different interest groups, PLCs and systems integration, even Industry 4.0, microcontrollers, things like that. And as part of that, we do these webinars every 2 weeks. So the next one is, for instance, on January 28th, and I don't know what the subject will be yet, but we'll talk about that at the end. So today's topic, and I don't see anybody else that's joined me here, is industrial training. And so there's a lot of different kinds of industrial training. For instance, there are engineering degrees that you would go to a major university of some kind, start out with something like a 4-year degree, a bachelor's. And some people go to school like this and they get their bachelor's, and then they stay in school and they get their master's, and they stay in school and get their PhD, and learn all there is to know about some specific topic related to possibly industrial automation. These courses, right, take a long time. If you're going into even a bachelor's degree, generally takes you about 4 years to complete, and then a master's is usually at least another 2 years, and then graduate studies can take anywhere from 2 to 4 years or more after that. We have a regular participant on here that's been working on his PhD. That's Phil Scruggs. I don't know if he's going to join us today, but Phil could probably tell us more about those graduate studies. And people that work on those kind of programs usually specialize in something. So for instance, Phil, we kind of did some traveling together, and he showed me what he was working on in school. He has an industrial engineering degree and an MBA and some other things. And he was working at Oak Ridge on some really high-tech vibration analysis stuff on, national instruments, platforms, and doing really high frequency analysis, very high tech stuff. But that got him into, for instance, doing some of the microcontrollers and Industry 4.0 topics. So that's why in some of the previous webinars we've talked about, using Arduinos, Raspberry Pis, ESP microcontrollers, and he's done some experimentation. And probably he learned a lot of that while going through school, right? He probably had to take some electrical classes on his way to his industrial engineering degree and then worked his way up. So I guess my take on this formal education is, I've kind of advertised this before. I got my bachelor's degree and I was a 30-year-old freshman in college. So I have a little different take on it. I already had experience in electronics. I'd been in the military for 8 years, and that's where I learned my initial stuff. But what I found about college was there was a whole lot of, math and theoretical things and science to physics and, chemistry and calculus and differential equations. And did those things help me? They certainly were necessary if you wanted to do electrical design. I would say if you're designing circuit boards and doing frequency analysis like Phil's doing, you need some of that higher math. But the thing that was missing is when I got out of college, I had a 4-year degree and I didn't know what any of the little components were that were used in industry. So I kind of knew the name PLC, but at the time, the PLC 5 was out, the SLC 500 wasn't quite out yet. So a PLC was a kind of a little bit kludgy for that time. You could do some pretty fancy things with it, but certainly in school, we didn't. They would spend an entire semester mostly just getting the PLC 5 to the point where it could do a little bit of programming, and programming was in DOS, wasn't very good. And so people didn't learn a lot in those classes. Now, I did learn a lot of things about circuit boards and digital electronics, but all that I've kind of forgotten now. I still have all my old books from college, so I don't know how much good all that really did me. I was shocked when I got out and went to work for a distributor systems integrator combination in Knoxville, Tennessee. And all of a sudden, there's all these components like, just even simple things, relays and timers. And the timers at that time, there wasn't as much solid state, so the timers were mechanical. They were motor driven, and there was all kinds of little, there was a clutch that would engage against the motor and turn the motor against the dial. And I had never seen anything like that. As a matter of fact, I'd never seen things like motor starters. I knew what a relay was. I didn't really know what a motor starter was with an overload, didn't know what a thermal overload was. So all that stuff that you would learn in college, normally, probably nowadays, I never learned. I didn't know what those things were. So where did my first learning come from? Well, the owner of the company and catalogs. I read catalogs, right? I knew the theory behind a lot of the stuff, but I just, I remember having an Eagle Signal catalog and a Pepperell and Fuchs catalog, and probably where I learned the most about sensors was Omron catalog. He was an Omron distributor, and I read those catalogs, and that's where I got a lot of my industrial knowledge from right after college. So, I'm a little bit cynical about these higher degrees, even though I realize that to get probably an entry-level job as an engineer, manufacturing engineer in a lot of plants, you have to have a 4 years degree. And interestingly enough, I deal with a lot of people from overseas. Let's see if anybody else is here. I see Tim here, so that's nice. I'm going to take a look and see if there's anybody from any other countries here. Nope, don't see anybody from out of the country. But an interesting thing about people from India who want to come here and work, they have to have at least a master's degree to come to this country and get a bachelor's degree job. And people kind of wonder, well, why is that? Well, a lot of these bachelor's and master's degrees, in my opinion, are checkboxes on a resume. You have to achieve a certain level to have the responsibility to get a certain job. And honestly, what they do with a lot of people from India and places like that that come here to work is they pay them like a bachelor's degree, but they have a master's degree person, and they kind of have something to hold over their head, because if they have to kind of sign a lot of paperwork and things like that to keep those people in this country and basically sponsor them to work. So I see, Vlad, you're on here. I was wondering if you had any input into that, because you kind of, I don't know if you're a Canadian citizen or if you're an American citizen, but you have a master's, and you came from a college in Canada, I believe, is where you went to college at. So, for instance, when you went to work for Procter and Gamble and things, were there any requirements like that? I know you're not from India or anything, but do you have any input on that, Vlad?
Yeah, sure, Frank. So I guess quick background. So I do have citizenship in both US and Canada. I studied at Concordia University up here in Montreal, Quebec. And so the requirement was that it needed to be ABET accredited for an engineering level position. And I say that with a caveat because they certainly, they did their due diligence and they looked into the college, and Concordia is an ABET accredited school, just like many other engineering schools in US and Canada and North America in general. That being said, I can tell you from personal experience that I did not know what a PLC was until, I stepped onto the floor. I had absolutely zero training when it comes to control systems, right? And of course, I had the calculus training, the differential equations, linear algebra, all that good stuff, but none of the, I would say, more practical knowledge that they expected. So they pretty much threw me under the metaphorical bus and told me, well, you got to figure this out. And so obviously, I would say the knowledge helps. I can tell you figuring out like how the signals flow, and I had a general, again, understanding of electronics, so you get some sense of how these systems should function, but I never knew what ladder logic programming was, right? I've seen C, for example, and I had to maybe in my head translate and reapply this in automation, but it was not taught to me in school. So I guess to your question, it needed to be ABET accredited as a program, but the knowledge itself was not really covering automation or control systems for that matter.
Okay, and what is your actual, like your undergraduate degree in?
So the electrical engineering.
Electrical. So the interesting, that's mine, right? And I actually got an electrical and computer engineering degree, but at that time, computers weren't anything, right? When I was in school, I was running a little lab, and we had Windows 3.1 had just come out. And I was a 30-year-old freshman at this time and running a little lab with that stuff. And we had some Macintosh also. Interestingly, I majored in controls. I actually specialized in controls. And like you, I knew what a PLC was. I chose not to take that class because I'd heard bad things about it. And and all the components, right? Took classes on motors, learned all kinds of good theory. And, we had a big motor and we did something with it. I don't even remember what, but it was all theory. It was magnetism and slip and calculations and lots of things, but there was no hands-on at the time. And this is probably typical of the formal universities, the non-mechatronics, right? Mechatronics is a big word now. And they have these pretty nice labs with some good equipment, but at the time they didn't.
Yeah, no, absolutely. I had the exact same experience. I could tell you, again, for, I guess, budgetary reasons or otherwise, even the equipment that I worked with was fairly old. We programmed the Motorola 68, I think it's 100 or 1000, microcontroller, which was one of the first like Apple controllers. And this was, I graduated in 2013. So that processor was actually, like, funny side story, was considered an antique on eBay. Because I did try to buy it for my house to practice on my own. But the point is, I think a lot of these programs are quite a few years or even decades behind than what the industry is.
So interestingly, I graduated 20 years before you. I was 33 at the time, and we used the 68HC11 Motorola chip, and it was probably almost the same class. We programmed it in assembly. It was nice. We did these little, some little breadboard things. I still have some of those breadboards, the old stuff, and built little circuits on it. It was a nice little class, but did it pertain to today's control systems? Not really. It did pertain, interestingly enough, to the Industry 4.0, Internet of Things that we're all doing now. So it's come in kind of handy. But the other note I'm going to put in here, again, because I do have some people that I talk to overseas, and I want to record this for those of you who are looking to get jobs in the United States, okay, because this comes up all the time. People want to send their resumes here. They want to try to get a job and I understand why, right? They pay a lot more here than they do in places like India and Pakistan, whatever. Unless you're already here, okay? You got to hear me well here. Unless you're already here, you're not going to get a job here, okay? If you're just sending your resume out, and even if you have that master's degree, you need to get here and you need to interview with companies. There are a lot of people looking for the exact same position you are. So again, I'm just going to tag this on here, and I may use it for later display, but please become the best at what you are, where you are, right? And I understand it's really hard to get work, and we have a pandemic and all kinds of things, but you're wasting time if you're sending resumes from India and trying to talk to people on LinkedIn to try to get jobs here. You know, there's lots of people already here from India, and they're looking for jobs here too. And they're trying to get sponsored and legally, whatever. So that's kind of how I wanted to end the formal part, right? The formal education part, because there are going to be people who look at this on YouTube and things and think, oh, you know, well, all I need is a master's degree from India, and I can come to the United States and work in a bachelor's position. It will be hard work. You will work extra hours. You'll be getting paid like a bachelor's degree. And that's kind of the way that works. So
I would add that, Frank, even from Canada, you know, I've had many engineering friends who graduated at the same time as me, and it's just as difficult to get across the border from Canada as it is, you know, from any of those countries, because I think there's a lot of opportunities in the US, but there's, as you said, internal candidates, and then the companies need to pay up in order to sponsor your visa, green card, or just, you know, work visa, whatever that may be. So it's just as difficult for a Canadian as anywhere else.
okay, yep. I wouldn't have guessed that. I would have thought it was a little easier because you can drive across the border. Of course, getting here to interview would be easier, which is good. You can drive from Toronto to Buffalo, you know, and go interview there or something. Okay, the next thing we're going to talk about, and Tim may have some input on this. I'm gonna quick jump to my little advertisements for here for everybody. Is I did put a lot of you guys' logos on here because I didn't know who was going to show up, but Vlad is Solus PLC, right, and has got a lot of good stuff on LinkedIn. You'll recognize some of these other ones. And Tim Wilburn, TW Controls. I know C's on here also. But you never know who's going to show up. But I teach for this company across the country. It's pretty much just on site. They ship you somewhere and train. So that's who some of the people that are on here on, and you'll hear a little bit from them possibly later. And you've already heard a little from Vlad. So the next I guess area would be you haven't necessarily gotten your bachelor's degree yet. You want to go to school for a mechatronics degree, maybe an associate's degree, and maybe even a bachelor's, right? Some of these junior colleges, you can get a bachelor's degree there, right? In Tennessee, we have a pretty big state system, and mechatronics degrees at a junior college, you can go all the way up to a bachelor's. These are pretty good programs in general. One of the things that I notice, at least here in Tennessee, is they buy a ton of this equipment, right? It's pretty high dollar equipment, and it generally comes from a company called Amatrol. I don't know if you're familiar with those. They're in Indiana, and they sell a lot of these same systems overseas. And then there are people, of course, that build these locally. Tim builds a lot of stuff. I don't know that he does it. I don't think he does it on a national level for the junior colleges, but he builds a lot of widgets and trainers and things like that too. The one downside that I see to these is, as you can see here, if you have a class of 20 people and you have one robot, you're going to be sharing the use of that robot with all 20 people. And by the time, and you're going to have a lot of in-class listening to people talk time. So your hands-on time for that specific robot may only be an hour or two in the entire semester that you're there, right? And that's just one class. So these are pretty expensive. But for instance, Pellissippi State right here in Tennessee, where I'm from, they put $8 million into their lab. And many companies donated equipment to that lab. A lot of people want to advertise their stuff. So, you know, Bertelkamp, which is a local extrusion manufacturer, made some nice frames for them, donated their stuff, put some pneumatics. I want to say they're maybe the brand pneumatics distributor, and they had some of their stuff on the trainers, and then they bought the rest of them from companies like Amatrol. The other thing about Amatrol is they provide the curriculum with the trainers. The curriculum, in my opinion, as a person who writes a lot of things and deals with high-tech stuff, is not very good. It was not written by people who are either particularly trainers or particularly experienced in true industrial automation. So I think what it mostly is it's a tool to sell their equipment, right? It's something that if you sell this equipment, you have to have a manual for it, and you have to have what it takes to make it run. But as far as learning something, the knowledge part, they use other books for that, right? So they're not going to sell you your electronics or robot theory book or anything like that. It's going to be more or less a user's manual. So we have a lot of these here. I do training for a company called Automation NTH that has a program called NTH University, and they take Mechatronics graduates from local schools here before they graduate, and they put them through a 4-month program in-house to teach them things like control panel building, operation of robots, PLC programming, pneumatics, all these things. So internships are another thing that would possibly fall under this, since I didn't make a separate a case for internships, right? But to get hands-on experience with a lot of this equipment, that's not in this formal education area, right? There's a lot more theory here, whereas here there's quite a bit more hands-on. But again, this is a little bit, I've talked to some of the instructors around here, and it's a little bit of the lowest common denominator theory here. And what I mean by that is the students that come in here, one of the instructors said, somebody will bring their son in who doesn't have any other plans after high school and say, I'm just going to put him in this program, and he needs to learn it. Well, what's his background? Well, he graduated high school, but he didn't apply himself, and he didn't do well in math or any of these other things. So I'm hoping he's going to take an interest in all these gadgets. The problem is now the class is somewhat restricted to the speed of that lowest common denominator. If there are people in the class that are really not prepared for technical material, it slows the class down. And that's kind of the feedback I got from a lot of the instructors here, at least here in Tennessee. And I can't speak for all the other places. So every junior college or whatever may be a little bit different. But what you're going to get here is, of course, you're going to get a program that is geared towards whatever the experience of that school was, right? It's going to run at the speed of probably the slowest students. So some of the higher capability students that maybe didn't have the money or the interest in going and getting a advanced degree may be a little bored here, right? They may not get to play with as much of the equipment, and the material's a little bit slow from their perspective, but they're kind of stuck with it. It's, to a degree, it's a more of a factory environment, right? We're processing students, and we're putting 20 or 25 people through a program at once. So that's one of the downsides to these types of programs. Also, I teach a lot of these instructors. This automation training company sends me around the country, and what I sometimes get is people that are, maybe they know Allen Bradley, but they need to brush up on Siemens, or they know a little bit about PLCs, but they want to teach a formal class. So I'll teach them, a 4-day class on control logics, and they don't have any PLC experience before that. Well, the problem there is they're taking somebody else's curriculum, and they really don't have a lot of industry experience. So what are they going to teach? They're going to teach they're going to take my 4-day class, and they're going to spread it out over 4 months, right, for the semester. And so what you're going to do is, you're going to learn a little bit about, the hardware, and then you're going to learn bits, and then you're going to learn timers, and you're going to learn counters and math, and you're going to have some canned exercises. And that's, once again, it's going to give you the idea of what a PLC is, but it's not going to prepare you for industry. You're not going to be programming when you get out from that class. You're just going to be familiar with what these different things are. And now split that up between all the little toys you see on here, right? You're learning pneumatics and robotics and, electrical wiring maybe, and what some of these different process things are. You may hear, for instance, what this e-stop is, but not necessarily go through the theory of what's behind it. What's all the safety circuits, right? All that stuff, there honestly isn't great curriculum. Now, if you want to learn it, of course, you can go online and learn all you want to learn about safety circuits and whatever. But that's a little bit of these, at least the local colleges here in Tennessee. I can't speak for the ones in California or in Canada or where Tim's from in Virginia. I don't know how much he's been in these little colleges and things, but that's my take on the ones here in Tennessee. Now, are they good? Yeah, they're a lot less expensive than this, right? If you want to go to the University of Tennessee or Georgia Tech or something like that, you're going to pay quite a bit, especially if you're from out of state. Whereas here, we actually have something in Tennessee called the Hope Scholarship. And if you can get into these colleges, you may get it for free. You may get your tuition paid for as long as you keep a certain GPA. So that's a little bit about how it works here. Any input from anybody else on these junior colleges mechatronic programs? Okay, well, we'll move on to the next one. I did something on this, a little video on YouTube about the STEM programs in high school. And this is another thing that we have locally here in Tennessee. As a matter of fact, I work with a local high school and go in and sometimes talk to the students in these programs. And once again, I think here they'll put some money into equipment. They will buy equipment for these high schools, but they don't really have a lot of curriculum for the teachers, which is why they depend on folks like me and maybe Tim Wilburn in the local area to come in and provide a little bit of industry experience. My guest, and this was about a year ago, maybe a little over a year ago, was Doug Allward. And we spent a lot of time in that webinar talking about the STEM programs in Tennessee. And he had a very interesting and kind of sad story about one of our local, we call it STEAM programs, right? By the way, those of you who don't know, that is science, technology, engineering, and math. STEAM was an attempt to add the A in there, which is, hey, we need some more on the arts, right? So now it's science, technology, engineering, arts, and math. And then some other people got upset and said, well, now we're avoiding reading and writing. So they made it STREAM, science, technology, reading, writing, engineering, arts, and math. Well, now you're just school, right? So it's kind of a funny thing. But anyway, his sad story was we both worked for a company called Wright Industries, very high-tech machine builder, good company. And they sponsored the STEM program for a local high school. The high school is an inner city high school here in Nashville. And when they started sponsoring it, the grades were not great in the high school. People weren't all that interested in technology, right? People get in trouble. So they decided to put in something like a STEM program. Wright sponsored it. Some of the engineers went out and donated their time. They bought some equipment. They started a robotics club. And within about 3 years had actually gone and won the state robotics competition. It was great. They had a lot of high-tech machine builder guys helping, engineers, programs going well. Wright Industries was bought by a company called JR Automation. And when JR bought Wright, they kind of took a vote within the company and said, well, what are we going to do for extracurricular activities? And they selected something else. It was a different program to give back to the community. But because of that, this high school lost their sponsorship from Wright Industries. And now they don't have a robotics program anymore because they don't have anybody that has the expertise in those kind of things like robotics or microcontrollers or whatever. So the last I've heard is it shrunk quite a bit. And then of course, COVID hits, and which, people aren't even going to school. So that's a sad story. They went from being a kind of an inner city rough school to having a really great STEM program for probably 10 years. And now they're back to not having much of a program at all. So that's one of the things, is that they may put a little bit of money into the hardware, but the people that teach it are really the key. And most of your typical high school teachers, one of the frustrating things for me, the local high school here, I called them up and engaged with them, and their STEM coordinator is actually the biology teacher, and her main interest in this area is agriculture. So they have a greenhouse. And so when I talked to her about the STEM program, I said, well, in that greenhouse, do you do any monitoring of moisture or, soil quality or any kind of technical, electronic monitoring of anything? And she said, no, we don't do any of that. So there wasn't a real in for me other than going in and talking to people about, Arduino, Raspberry Pi, microcontrollers, Node-RED, a little bit about that, talk about the industry and how it works. But anyway, so that's been my experience with the high school STEM programs. Tim, I had heard, and I want to see if Tim's even still on here. I haven't seen whether he's live. Tim, I see Tim's on here. Tim, I think, donated some time or teaches local high school students at his facility. Do you, Tim? Well, I see Tim's on here, but he's not answering his phone.
Yeah, I am. I just got done over at the high school, and yeah, I'm pretty brain fried. So yeah, I'm listening, but I'm not conversing that much. I just got done today, and yeah, it went insanely well. And hopefully, I'll have more to share about it next week.
Awesome. So yeah, I'd encourage anybody to attend Tim's webcasts and experiences on the high school programs. Again, people donating their time and going in and doing that is the key to these, right? The STEM programs, STEAM. Without those industry people, those high school teachers just don't know the industry, right? They know whatever they're teaching in high school, but they don't really know our field. And so even when they get some decent equipment, they don't always know how to use it. And so that's a bit of a problem. So, any other comments on high school STEM programs, any of that, or even going back to the formal education? Anybody who had some experiences want to say anything? Or
Frank, I had a junior college experience where I had enough money to go through one semester. I got on scholarships. I was the first transfer scholarship back in Kansas City to the University of Missouri, where I completed electrical engineering. And those kinds of things where if you will put in the effort to earn it, there's support for you. There's stipends and this and that. And I'm one of the beneficiaries of that. And I just wanted to echo back that you were doing it at a little bit lower level. I just love the idea. Yeah.
Oh, absolutely. Yeah. So, and so there are very positive things about getting your hands on the equipment. I think that's one of the strongest points in both of these cases is they do put some money into the equipment. So a driven student might be able to teach themselves a lot of things, even if the material is not great, right, necessarily in the junior colleges. But nowadays, of course, you can get so much of this knowledge off YouTube and everything, and then you have access to hands-on with the equipment, which is awesome. Or even buy it yourself, right? Buying the microprocessor stuff is really not that expensive. The next thing I'm going to move on to here, and a bunch of people on here do this kind of thing. I know Tim Wilburn does this. Whoop, it just kind of flipped here. There we go. Yeah, my mouse is moving itself, which is not good. So these are a couple pictures of classes that I do, so I don't have pictures of other people's classes. I don't know what they look like. The one on the left is a typical hotel class. And so what I do is I teach for a company that's in Canada, automation training. And what they do is they book classes all over the country, and they're typically 3 or 4 day classes. And this one is a good case in point. It was a regional class. So all the people you see in here, you see a guy with a mask in the front. They come to these area classes, and we ship these little trainers, or automation training does. And see, there's a ControlLogix PLC in there. It's got little push buttons and things on the front of it, like these things behind me, right? Some of these are other trainers that I built. But what you get with that, you don't have a little toy factory necessarily, right? You have push buttons and you have pilot lights. The class is going to be canned, very much like the a semester at the junior college, right? It is has been written up, and it's a tested lesson plan. And again, people do, bits, and then they do timers, and then they do counters. They learn the hardware. They do some math. I'm, kind of into customizing classes. So if I've got a bunch of guys from oil and gas, that's what I'm going to talk. I'm going to talk process control. If I've got a bunch of guys from pharmaceutical, I'm going to talk about validated software, and I'm going to talk about high-tech mechanisms and how PLCs interface with robots, right? If you're doing semiconductors. So every instructor is a little different, but the nice thing about automation training is they only hire guys anyway with 20 years of experience in industry. So all the instructors are going to have some things to put their own spin on the class. It will be particular to, hopefully, to whatever the industry is. Now, the one on the right, this is my old facility, the one that got destroyed by the tornado. 107, 6650 Suite 107. This was my old place. And I had a facility that could teach about 8 people at a time. And sometimes automation training would send students to my facility, and sometimes I'd recruit my own students. Around the corner here, and you can't really see it, but I had a little toy factory. And for those of you who want to see that, it's on my website and various other places, maybe even on my LinkedIn profile. But I had a little fake factory, and these guys were all from Automation NTH, which is a local engineering company. And twice a year, they send their interns out, and they took a 1-week class, and they would work. In general, we did a lot more machine-specific simulation, right? These people have already been through PLC classes. So they know how PLCs work. They've done videos, they've done other things, and then they move on to more advanced subjects. And usually the employees, so what I had here is these 2 people in the back corner were the advanced students. They were already employees. They've been through one of these classes. The other 6, I think, here were all interns. And the employees go around the corner and they work on my toy factory. And there's 2 pick and places, and there's a dial table and a indexing conveyor and a vision system, and they work on that. So they get to actually integrate a small machine. They write the HMI code, they write the PLC code, they write the little interface for the dial table, and they get a lot out of it for 1 week. So it's truly a little more hands-on. But again, I don't have like Amatrol equipment. I looked into that, and I looked into Amatrol building me something like my toy factory, and it was going to cost me $50,000. I said, well, I'll just build my own, right? At that point, that's a lot of money to put into something that only 1 or 2 people can use at a time anyway. That's the thing. You can't fit more people than that. So that's a little bit of the industrial training that is hands-on or in person, right? There are a bunch of companies that do this. Automation training is not the only one that has regional classes. If you're in California and you want to take a PLC class, there's somebody there that will put one in a hotel in your local area. For what I know, Allen Bradley themselves do it. Siemens does it, right? So you can go get in-person training, or something closely related to it would be video in-person training, and automation training does that. They'll have cameras, and you remote desktop in, and instead of using a physical trainer like this, you'll just have a little HMI, and you push the buttons on the HMI and it pushes the buttons and things. But it's the same exact curriculum that's on here. So that's another way to learn. And of course, with COVID, that's, a lot of people are migrating to that rather than in person. You can just do it online, live, ask the instructor the questions. I don't tend to do those. For one thing, I don't have really the setup where I can monitor 4 or 5 remote desktop connections. So I don't do that particular thing, but I do teach in-person on-site classes. Headed out to one at the end of this month out in North Carolina, that somebody just called me up and they said, we need training for 2 people. Yeah, if you're willing to pay my trip out there and my time, I can teach 2 people. Of course, that's going to be customized. As a matter of fact, it's a pharmaceutical company, and I work a lot in the medical devices and pharmaceuticals, so I can go and connect up to their machine and teach them on their own machine. I'll go through it and explain how the logic works, and it happens to be Siemens Step 7. I'm pretty conversant about 4 or 5 different platforms. So I can teach those in pretty good depth. But that's the way these work, whether it's by bigger companies or independent people. Another program closely related, these are pictures from Automation NTH, and I mentioned that I now work for them 2 weeks every month. And they have this program called NTH University. Again, it's a 4-month program for interns or what they call apprentices. An apprentice would be somebody that had graduated from college and comes in without a lot of the knowledge, the experience. They will put them through the same 4-month program. They start out with basic controls, a little bit of basic PLC stuff. Then they go work in the panel shop, and it's a UL panel shop. They draw the panels in CAD. So they work first in AutoCAD, drawing electrical schematics and everything. Then they go work in the back. You can see the picture through this door right back here is the panel shop, right? You go back there and you work there for about a month. So I think they get probably a month of general controls and drawing, and then they get another month of panel building, right? UL panel building, and learning what all the components are, hands-on. Then they come back in to this lab and they get a project and have to make their own. They have this little conveyor system. You can see it right here. And they have to make this work on first Allen Bradley 500 and then 5,000, right? They learn that. And then they get assigned a random controller. And the random controller could be Modicon, it could be Mitsubishi, it could be a building controller, right? A building automation systems controller. It could be an Arduino. Somebody did one on IO-Link, right? So there are a whole lot of different panels that have been built, kind of back here on the wall, probably 40 or 50 of them at this point that have been designed by these interns and apprentices. And they finish that, and then at that point, Automation NTH decides, are we going to hire this person, right? They interview them, but they know, hey, they have 4 months of training in the way we do things. So that's kind of a neat program, NTH University. And again, I work 2 weeks every month down there. They're about 25 miles from me here. And I drive down there and do either in-person training or just content development for them. So that's another thing that I would equate this to. Some bigger companies have internal training, right? Like Nissan in our area has a pretty good maintenance training program with a lot of this equipment. And the maintenance people get hands-on training before they go on, unfortunately, third shift, right? That's where people start at Nissan. But they do get some hands-on stuff after they're out of college or junior college or whatever and get some experience. So I would put this in almost the apprenticeship category. So it takes a pretty good sized company to be able to afford to do that, right? To invest in their workers and put them through, a formal training program like this out of their own facility. And then there's other companies that send people to like automation training or a 4-day class or Tim's class, or I think Vlad, right? A lot of his Solus PLC material is sold to companies. So a company may buy a license, right, for the training, for video training. So that's how companies kind of invest back in their employees. Again, this was a little bit of advertising of some of the different companies that do either hands-on or video training, web and recorded classes. This is Vlad's company here. There's again, Tim's. This automation training is the company I contract to in Canada. This is Sean Tierney, Automation School. He's been doing this for 20 years. And he sells individual videos or again, corporate stuff. This guy, Don Fitchett, I don't know a ton about his, but he bought a company called Coldwater Software, and he has some software from them. They do pneumatics and industrial training, electronics, and some PLC classes. I don't know much about them. And then this is a young guy who I've kind of watched come up, my PLC training, and his is very much specific to electricians that want to become a better, a more confident PLC programmer. So it's very much at the entry level, but I think what he's doing it kind of the smart way. He's niched his market down to where he is specifically industrial electricians without any PLC experience. That's his target audience. and he does a good job. He markets things pretty well. This one down here is interesting. This is the PLC Dojo, which came from, grew out of Paul Lynn's Udemy classes. And Paul Lynn, I want to say, was probably the first and the biggest on Udemy and did very well with it. And he's a good teacher. He has a very calm voice. I've listened to some of his videos, and he has a very calming, almost like a yoga or meditation kind of voice, and does a good job of explaining things. And then left Udemy, and I don't know if he actually left them, but he started a thing called the PLC Dojo, and he does a good job with that. This is my own Automation Academy. I explained what that was at the beginning of the webinar. It is a membership site, which is a different thing. PLC classes on there, but a whole lot of stuff more on systems integration and recorded webinars like this, and just me talking about integration, pneumatics or Industry 4.0 or microcontrollers or whatever the subject of the day happens to be. So that's just a little bit of the background of all these different types of industrial training that there is. I don't think I've left anything major out. We went from the beginning of bachelor's, graduate studies, formal education in colleges, associates, mechatronics, and even bachelor's degrees. There's a little overlap there with the big colleges, right? And then high school and STEM, that's where it all kind of starts. Another thing I'm going to mention here, we have a local company that actually has an after-school STEM program, and they gear it toward junior high school kids and give them some hands-on stuff and have some little toy robots that they chase around and things. And I think they stop actually at the end of junior high school, but it's a local paid STEM program, right? Where people can put their kids into a program and learn something extra after school. So that's kind of neat. It's called Braingineers for those of you who are in Nashville, Tennessee. And the Braingineers program is in Mount Juliet, close to me. And I go talk to them sometimes, just about whatever. So I try to get involved in the local activities. Then we talked about the Onsite and Regional, which some of these are traveling classes or institutional classes. And then there's little people like me with a little office. Now I'm in a house, right? And I can teach, instead of teaching 8 people like this, I can do 4, right? And most of the students I'm getting now are trying to solve a specific problem. I had one of my guests was Lucas Wetton, and he was doing his dust collection system. He took a class thinking it was going to be a PLC programming class. And I said, that's about a 2-hour class. Your dust collection system is very simple, but your electrical design, that's a whole different animal. And so we did that. We spent most of his week here on electrical design and specification of components. And, he had a 50 horsepower drive on there and all the associated components that go with that. He'd never built a panel and didn't know electricity all that well. He picked up the programming like that because it was honestly a very simple program, right? You just turn on a big fan and a conveyor and you have some safety stuff. So the PLC wasn't even the point for him. We ended up going farther into design. And then we have, I kind of put NTH University, and I would put this into, again, apprenticeships. If companies have, an apprenticeship program or an in-house training program, that falls into this category where the company buys all the equipment. They have a lab. Some companies, Under Armour, right here in my area, they have a bunch of drives and PLCs up on the wall. And what they do is they say to the employees, maintenance people, hey, here's all this equipment. You can come up and experiment, and you can wire this stuff on the wall, and you can disconnect it, and you can take your meter and check everything. The problem they have there is that there's no curriculum with that, because most maintenance managers, who are the people who built this thing on the wall on the pegboard, don't know how to write a curriculum for a class. So the maintenance people at that particular plant have mentioned that, hey, there's not a lot of motivation to go in there and just start playing around. And sometimes you don't even have time to do that, right? You're busy chasing equipment, but they do have equipment on the wall like this thing you see back here, right? It's hard to see here, but there's a big board with a bunch of PLCs on it. And they do that in some of these plants too, right? Pegboards and motor starters and emergency stop circuits and things like that. And then moved on to the online training, of which there are lots of resources. So at that point, we're about 45 minutes into this. A few people on here. Any comments, questions?
Hey, can you hear me?
Yeah, yeah, I hear you.
Yeah, I was just going to say most of my experience up until now was more on the service side with building automation.
Yes.
And the biggest thing, like what you're saying, is the hands-on aspect of it. I've worked in building automation. I also worked for Vistacon, which is now J&J Vision in manufacturing. And the machinery they have there is pretty crazy because you're talking about a machine with, I think, close to 40,000 IO points in each machine.
Yep.
Because you build the contacts from raw materials to in the little package in the box that they go in when they ship out. It's
I have a
very
surprise
amazing
for you.
piece of equipment.
What's your first name?
Jeff.
I built you guys a machine in 1990, well, maybe 2002. It was a
Okay,
little
so that was the
contact
first gen.
What's that?
That was the first gen stuff. The stuff that I worked on was made by Tokyo Automated Machines.
Cool.
So
the
it
one
was
I built was out of extrusion and inspected contact lenses with your cameras. They were computer-based cameras, and they inspected. It had a little indexing palette and inspected contact lenses one at a time.
Oh, they've gone really far with that stuff now. They use Cognix cameras and in-house software for inspecting them. It's pretty impressive.
Yeah, I tried to persuade them to do Cognix back then, and they had their own stuff. They were great big old monster cameras mounted over this animatics indexing system, and it was a one-off machine. I just built one for them, and that may have been when they were just first getting into it. Very cool.
But yeah, that was the biggest thing with me was the experience aspect. So when I did the building automation stuff, the equipment that we used was Andover controls. So we did everything from running the plant to air handlers and including card access. And I had to go teach a class because one of our engineers was sick and I was just a service tech guy. But that was my big thing coming up with a curriculum was to say, I'll have a test bench, have a controller and a main controller, and basically come up with everything I can think of to screw it up so that those guys would have to hands-on go back and fix it. And I came up with one that was ingenious. It used ACC lawn, which was an Andover proprietary lawn, but it was open topology. So you could switch positive and negative and it didn't matter. It would auto switch internally.
Wow.
Yeah, it's weird. So what I did was just take one of the wires and cut it shorter and put one wire under the terminal and the other one was just the rubber, just the jacket. But the little comm light would still flash, so it looked like it was online, but it wasn't. And it took them about an hour to figure it out because I said, you got to keep looking. It's not online. What's wrong with it? And finally they got down there and one guy's like, you know what? One of the electricians took the wires loose and he goes, this is what's wrong with it. So it was pretty good though. But I mean, you run into weird stuff like that. So you never know.
Yeah, we're doing the same thing at Automation NTH. It's probably hard to see here, but we have these trainers and then we have these conveyors, and there's a cable that runs from the trainer to the conveyor. And Dexcom, which is a local company, has asked for a troubleshooter to put in the middle of that cable. So now you disconnect the cable between the controller and the conveyor, and you can turn different wires on and off, and you can also randomly do exactly what you were talking about. Take any one of those wires and just kind of pulse it. So it gives you an intermittent problem, right? Hey, well, it was running a second ago and then it stopped and now seems to be okay. So then they get their meter out and they check everything in either in the little conveyor box or in the controller. And yeah.
It's like a breakout box. When I worked on cars, that's the one thing no dealership ever had. Nobody ever had a breakout box. Like, that'd be great if you could, you got 80 pins here. It'd be a lot easier to troubleshoot this. We have a breakout. No one ever bought them. They cost too much.
Yeah. Well, and it's expensive. This they don't really market this Automation NTH, but that controller box is $4,500. The conveyor itself is another $4,500. And it's proprietary. It has a specific cable that goes between it. And this troubleshooter is going to be another several $1,000s. This is not available for individual people necessarily. And of course, you can't ship it around the country easily without crating it up and doing things. So people don't get these in the regional classes. They're specific to a company pretty much.
Right.
Who can afford it. Or, this robot trainer. This is one of those things. Local vendor brought their Epson. You can see another Epson over in the corner, a little Scarab, but they brought in their own thing. They spent a day setting it all up and then, taught an Epson class and then tore it all down and brought it back to their shop. But you don't see these traveling as much around the country and doing things. So
No, and the robots are pretty expensive too.
They are. They are. The Scaras are less so, but then you don't get the true like world coordinate stuff that you get from the 6-axis. So, and again, they use a ton of Epson robots here, so it's worth getting that specific training. But what if, you're a systems integrator and you do, GE Fanuc and Denso and, Adept, and, you're going to get training on one, but how do you get training on all of them? That's a whole different thing.
Right.
All right. Well, it was good to see everybody. And some of the people that have attended today are the people who put these programs together. Anybody want to say anything about their particular program, Vlad or Tim, about your online training classes and your videos?
Just wanted to thank you, Frank, for putting these, meetups together. I really appreciate, talking about this. I think there's certainly good conversations to be had. And I know that on LinkedIn, people bring up how education is not where it needs to be, but I think this is what's really going to push the industry forward, right? And I guess a shout out to Tim, who did a high school class this week. I think you saw maybe some of his posts, but I think really that's what we need in the industry more of than I would say just the negative thinking. So I really appreciate this, and I guess Tim putting together something concrete for the younger generation to get into automation. Thank you.
Exactly. And a lot of the gadgets, right? Getting kids involved in the microcontrollers and Arduinos and things like that at a young age, little toy robots. There are all kind of programs for that and all kind of inexpensive hardware. And so I'm at the age now, I got 4 grandkids, and one of them shows a whole lot of interest in gadgets and tools. So trying to get him exposed to things that are simpler and inexpensive is a great way to get people into some of these programs, and then show interest, and it keeps them out of trouble when they do get into school. So the next webinar is going to be January 28th, about 2 weeks. I think I'm in North Carolina at that time, so I'm not really sure what the guest or the topic's going to be. On my list is to do something on cybersecurity and a little bit more on Industry 4.0. I think we've talked certain topics to death, things like PLCs and some of those things, but hoping to get a guest on, again, specifically cybersecurity, networks, things like that. And thanks for showing up. I'm going to go ahead and get everybody's pretty faces on here and say hello. So Hank's got a picture on there. Hank looks very stern. Just a still picture there.
I'm standing on the deck of the USS Yorktown in South Carolina doing a selfie.
Wow.
That was a startup we did down there for one of our customers back in the summer.
Very fun. Yeah, that's a very good stern picture there.
There, see, I do smile.
Cool. And Jorge, how you doing? Oh, you're muted.
Hi, Frank. I'm from Mexico.
From Mexico?
Mexico, from Sonora, Mexico.
Sonora. I grew up in Tucson.
Yeah.
Yeah, I used to drive across the border, go to Hermosillo or Ciudad Obregón, Nogales, right? Yeah.
I live in Cananea.
Cananea, yeah. Not far
it's
from
around
Arizona.
Half hour from Arizona.
Yeah, that's right. Yeah. We used to drive down there for lunch. You could go to Nogales for lunch in an hour, but nowadays there's a lot more traffic, and you can't just cross into Mexico so easy anymore either. So that's cool to see you. Yeah.
Okay. I'm starting my journey on automation. Yeah. Okay.
Well, some of the guys you see here, Vlad and Tim and some of those folks are other people who can really help you. So by all means, on LinkedIn is a great way to reach out and touch base with people, and you can learn a lot.
Okay. Thank you, Frank.
Okay. Well,
reading to all of us.
Oh yeah. Well, thanks. So the other thing, I guess I'll make a little announcement here. I am finishing finally my latest book. That book, at one point, I actually contemplated writing a book on machine vision. And I decided at the last minute to take the machine vision and stick it in this latest book. So it's going to have PLCs, pneumatics, hydraulics, machine vision, very brief PLCs, because I've already written a book on PLC. So I don't want to, I just took some of the beginning part of it out there and stuck that in there. And what else? OEE, some things on OEE, a little bit on Six Sigma, and a very good schematic interpretation troubleshooting program from something they call the Sweet Machine at NTH University. What is interesting about it, it's got a safety PLC on it. It uses IO link. It uses, it's got machine vision on it. It's got a robot on it. And so what I'm doing there is I'm taking apart all the schematics and relating them to the components in the panel and talking about how you would go troubleshoot such a system. It's pretty elaborate because there's, again, IO links, another world. So that is something that I'm doing in partnership with NTH University, but it's going to be published like a regular book and people can buy it. It's just going to have an NTH University logo on it and be sort of like my last book. So that's kind of the last minute thing of what I'm working on. That should be out within a couple months, hopefully. But great to see everybody. And I'll probably kind of end it up here. Dan, I'm getting familiar with you. You show up. He's Alicia's biggest fan, I think. Dan,
yeah, I choose my friends wisely. I've been in touch with Vladimir and recently with Tim. I complimented Tim's dance. Did I take a risk there?
His dance. I haven't seen that one. He's got some good videos.
God, we should have played that. So for the next show, let the audience know that there was some demand to see Tim Wellborn's dance.
Well, I think they'll have to log into Tim's webinar themselves to see that. Yeah.
A closing comment a bit, Frank, and to tie in all the people I just mentioned, the kindness and generosity from all the leaders of the industry is so helpful to me. I'm like a legacy intern. I'm long in the tooth, got gray whiskers, and I'm new in automation. And all of the kindness keeps me going. And there's good things starting to come my way. And I'm just going to stay at it, and I'm going to try to stay active.
Well, that's a good thing. Yeah. You know, LinkedIn, again, is a great way to connect everybody together. And we form all our little communities. And I've even got a little Facebook group, but it's a whole different thing. And we don't have anywhere near the community that we have on LinkedIn there. So I don't do as much there, but it's great seeing everybody. And any other last minute comments or anything before I shut it off?
Thank you again, Frank. Really appreciate it.
Thank you. And it was great seeing everybody. Thanks for showing up today.
Yeah, thanks, everybody. Y'all take care.
Take care. Cheers.
You too.